Okay, let's talk about multiplying and dividing rational expressions. I think you're going to find this a quick, easy lesson. The rules for multiplying the rational expressions are exactly the same as for multiplying fractions. You multiply the numerators, you multiply the denominators. So in this case, I could go straight across and multiply 12 times 15, get a very large number. I could multiply 25 times 36, get a very small number. Okay? But I think most of you would probably say, well, wait a minute, let me reduce first, or you call it cross-canceling. And what number that you can think of that will go into 12 and 36? 12. So 12 will go into here one time. 12 will go into here three times, okay? What about 25 and 15? I would say that's 5. 5 will go into here 5 times. 5 will go into here 3 times. Now, here's the part that we might not think about. What about a 3 over a 3? Can those cancel out? Yes, as long as you are canceling out a factor on the top with a factor on the bottom, you're good. So 3 will go into here one time, 3 will go into here one time. What am I left with? On the top, I'm left with 1 times 1. On the bottom, I'm left with 5 times 1, so that is 1/5. We're going to do the same thing with the rational expressions. But again, please remember, you cannot cancel out until you have factored. You can never cancel out a piece of a binomial or a trinomial or any polynomial other than a monomial. So in this case, I need to look at every numerator and every denominator and make sure that it is factored. And I notice that this binomial cannot be factored. That's a monomial. That's a monomial. This binomial can be factored. You can factor out a GCF, and that leaves you with a C minus 1. Now let's cross cancel. Well, the C minus 1 cancels with the C minus 1. Again, remember, the whole entire binomial needs to cancel out with the exact same binomial. We've got 2 and 4. 2 will go into here one time. 2 will go into here 2 times. I think I'm finished. What do I have left on the top? I have a 2. On the bottom, I have a 3. So that whole thing reduced to 2/3. Okay? So now what I want you to do is pause the video, and I want you to try these two first. And let me give you a minute to go ahead and pause the video, work these out on a piece of paper, and then let's check your answers here in just a second. Okay, here we go. I have a monomial, a monomial, a monomial, a monomial. So there's no factoring that I have to do. Let's start canceling out. 8 will go into here one time. 8 will go into here 2 times. 5 will go into here one time. 5 will go into here 2 times. Let's work with the variables now. Ready? A y cubed is divided by a y cubed. The z squares can cancel out. Okay? This y right here can take one y from here, and there were no x's on the bottom. Let's see what we have left. We have a 2x squared y on the top and just a 2 on the bottom. Well, I didn't even see that. Look at that. Those 2's can cancel out, and you're left with an x squared y. This next one is a little bit more difficult, but only because the factoring is a little more difficult. All right? This is a fraction if you put it over 1. And again, I cannot cancel out any piece of a binomial, trinomial, or any other polynomial other than a monomial. So this 6x does not cancel with this 6x. This 9 does not cancel with the 18. I have to factor this. This is a perfect squared trinomial. That's going to be x minus 3 times x minus 3. I'm going to go ahead and write it twice. I'm going to mark through this. Okay, this is a monomial, so it cannot be factored. This, you can take out a GCF, which is 6, which is going to give me x minus 3. Okay, again, cross through that. What can cancel out? Well, an x minus 3 can cancel with an x minus 3. The 2 and the 6 can reduce. That's a 1 and a 3. And what do we have left? On the top, I believe we have a x minus 3 and then an x from here. On the bottom, we just have a 3, and that is it. Okay? Try this one. Pause the video again. Try this one. Okay. Again, make sure everything's factored. This is not. I'm going to pull out a -4 and that's going to make this a c minus 4. Now, if I had just pulled out a positive 4, I would have nothing to cancel out. So what can cancel out here? Well, I'm going to say a c minus 4 cancels with a c minus 4. I'm going to say 5 will go into here 1 time. It'll go into here 9 times. I think that that's it. And what am I left with? 9 over negative 4. This is not that bad, okay? So basically there's two methods for doing this. You can either simplify first by canceling out, or you can multiply first and then simplify. You're going to get the same answer. It's just that if you use the second method, you tend to be working with larger polynomials, larger numbers, and it ends up being a little bit more messy. Plus, in many cases, you turn around and have to factor out a GCF, which in this case, if I were to multiply straight across, I would have to take this binomial times this monomial, and I would have to use the distributive property. And factoring out the GCF is just doing the distributive property backwards. Okay? So again, I wouldn't recommend the second method. I would recommend that you simplify first and then go from there. Okay? All right, go ahead and try this one. Again, this one is a little bit more difficult. Pause the video and do that. This is good practice for you. All right, let's go ahead and do this one. Ready? That binomial cannot be factored. This, I can take out an n, and that leaves me with an n plus 4. Okay, this is a perfect square trinomial, which is an n plus 4 times an n plus 4. Okay, that's been factored, that's been factored. And this one is going to be n minus 5 times n plus 2. Okay, so again, so I just factored each one of those. Cancel out your common factors. Well, an n minus 5 takes an n minus 5. One of these n plus 4s on the top takes this n plus 4 on the bottom. And what do I have left? Sometimes if I get to the point that it's like getting too messy here, I just go ahead and write down what I have left. What I have, an n plus 4 left on the top, and an n plus 2 on the bottom. I can look at those. Remember, there's like parentheses around this. So n plus 4, there's not anything to cancel out with on the bottom. So we are finished. All right. Let's go ahead and divide. Really simple. Same rules as fractions. Keep it, change it, flip it. You are going to take whatever division they give you. You're going to keep the first fraction the same that it is. You're going to change the division to multiplication, and you're going to flip over the second fraction. Do not factor or cancel or do anything else until you have done these 3 steps. Keep it, change it, flip it, okay? Then you're just dealing with a multiplication problem. So let's go ahead and do this one right here, and then I'm going to have you do the next 2. Ready? Keep it, change it, flip it. Okay? Make sure everything's factored. It is. What can cancel out? Well, this G right here will cancel out with one of these G's up here. It'll leave me a G. What do I have left? On the top, I have 2G. On the bottom, I have G plus 4. Okay, so go ahead and pause the video and do the next 2. Scroll down here. Do these 2 problems. Okay, these are the last 2. So ready? Keep it, change it, flip it. So keep the first fraction the way it is. Again, don't do anything. Change this to multiplication. Flip over the second expression. Before you can cancel anything out, please make sure that everything is factored. I think this looks backwards to me, so I'm going to pull out a negative 1, which is going to make that n squared minus 1. Then I can see that I can actually factor that further. Let me get rid of some of this so I have a little bit of room up here. Okay, so this is going to be negative 1 times n plus 1, n minus 1. I hope you can see how important the factoring is. Okay, here I can take out an n, and that's going to give me an n minus 4. All right, now what can cancel out? An n minus 1 cancels with an n minus 1. The n cancels with an n. What am I left with? Negative 1, n plus 1 times n minus 4. Everything is canceled out on the bottom, which makes that a 1. You don't have to write that down. Okay? That would be that one. All right, let's look at this last one right here. Keep it, change it, flip it. Remember, this was over 1, so that's going to be 1 over 2x squared plus 6x. Factor before you cancel. That's a monomial, so he's okay. That's a monomial. That's a monomial. This one you need to factor out a 2x, and that's going to give me x plus 3. Okay? What can we cancel out? Well, the 2 will cancel with the 4. The x's will cancel out. This y will cancel with one of the y's on the top. What do we have left? I have 2y times 1 on the top and x plus 3 on the bottom, and we are finished. And that's it. Okay? Have fun with these.